Okay, so yesterday we talked about malonic ester synthesis. Very, very similar to acetoacetic ester synthesis, at least in how you go about it, and the steps that you're going to take, the reaction steps, and the mechanism by which those steps go. You don't have to be able to write the mechanism. You do have to be able to give me the 5 steps. And when you count 5 steps, one of them is saponification, and there's a whole, acidification right after that is a whole numbered step by itself. Like, those are 2 different steps, even though they're just put one above, put a 1 and then a 2, and then just put those, and yeah, those count as 2 different steps. So, anyway, they, however, give us different products. So, malonic ester syntheses, they give us, carboxylic acids with stuff on their alpha carbon. The acetoacetic ester gives us an alpha beta unsubstituted carbonyl aldehyde or aldehyde or ketone. So for retrosynthetic analysis for this guy, I want you to be able to look at a product and tell me how you would go about getting that. We didn't really talk about this yesterday. So let's do that. They've color-coded things, but you're not going to have that initially, right? Initially, you're just going to have this. So it's up to us to figure out how to color code. First, we're going to find our nucleophile, right? Our nucleophile is, now, it looks like I'm coloring that, this is going to be our nucleophile. Yes, there's a hydrogen still there, but we're not deprotonating that, right? We're doing backward synthesis. So this was our nucleophile, and this is where it's ended up, right? That means that our substituents, get rid of all of these lids. Are that. You know what? Let's do something more interesting. We're going to do that, and we're going to do we're going to do this. I don't know, why not, right? It's cooler than that. There's more lines to draw. Plus I get to draw my hexagons. I love drawing those. All right, so those guys are our substituents, right? So the first retrosynthetic step, or the first undoing of this, is to go back to our ester. So we're going to start with this, but now it's ETO, that, right? And we know that, well, basically, we're going to start with that. I could, maybe I should draw it down. A lot of times we draw it like this, right? That's going to be one of the things we're starting from. I'm trying to go back to the beginning, but that's not where we should go yet. So we should go to, we should take one of these guys off. Which one do you want to do first, green or blue?
Green.
Green. Let's get rid of green. So that means that at this stage we have that still attached, and we have, wait a minute, this is what happens when I make things up. fine, it can be very similar to this, but how do we add these? We do an SN2 reaction, right? So, can we do an SN2 on a benzoic carbon? No. So let's do that, and then we can have, my hexagon's getting away from me. There. Fixed it. Now we're okay. Because these are the carbon attachment points, right? So they have to be, you know, not on the aromatic ring. All right, now we can have the other substituent, and the other substituent is that has a point up there. A nice little ring with a carbon and then a leaving group. So bromine, I don't know, it's always bromine. We love bromine. Iodine's more expensive, it goes faster. Let's see. Yeah. So here we go. If we're actually trying to do, if your book or the problem wants you to do the forward reaction for this, you actually have to put the conditions, right, or the other reagents. These are the reactants. These are like the things that the carbons come from. Reagents are just other stuff that doesn't really, you know, if you're doing a retrosynthetic, you don't really look at them, but like, oh yeah, what else would we need? That would be NaOET, right? Basically that's it. Oh, that would be a step, NaOET, and then you'd have another step, OH minus, for saponification, and then you'd have another step, HCl, H2O, and then heat, right? Because those are the add and then get rid of. So, we haven't gotten rid of everything yet. Let's do another undo step. We're gonna have ETO mountains. Oh, I don't know what I'm doing. Oh, ET, we've got, that's our nucleophile, and now we've got to take this guy off. So, how many carbons are going to be in our substituent? Yes?
What is the heat for?
Heat is because we get to, so after we do saponification to get rid of these, and we've just got O minus,
Yeah.
we do acidification to make these OHs. So we've got, when you do it this way, that, and then we've got okay. Then we do mild heat. We've got an if this is our carbonyl, alpha, beta. So we've got a beta
Carboxyl.
carboxyl. So we do lone pairs are important. And we do, hey, can I have that hydrogen? And it's like, yeah, all right, but I'm gonna take that and go bind here. And that carbon's like, hey, I can be CO2 and just live my life the way that I want to. And we do that, and we get, that's an OH. We get this piecing off as CO2, and we get ow, God, my knees are so old. What happened? Oh, okay. When I moved this over to here, I I'm trying to make 5 bonds there, so let's actually have this double bond be the electrons that take that. That's better. Now we've got a double bond there, and then we've got terrible bond angles, but whatever. So, yeah, this is the first, well, and then this undergoes keto-enol tautomerization, so that in the end we get, never mind, not this anymore, now it's this.
Okay.
Yeah. So, yeah, this is the heat, step. I'm just sort of doing the, like, what would we need to add steps, which is not, maybe shortcuts, but yeah. So the first undoing of this is going to be 2 carboxylic acids with your substituents on there. The second undoing of this, I guess technically the second undoing of this is, since if they're going to count it as 5 steps, then saponification and acidification are separate. So the next undoing, if you want to get really technical, is just this with the stuff attached, and then we go another step, and we get this with both steps attached. Why am I writing it backwards? With both the stuff attached, and then we go to the step where we take off one of the stuff. Yeah? Did that get too messy, or is that kind of
That's good.
okay? Can I see? Okay. I just want to see some more people doing some sort of like, no, I'm not, or like, yes, because the frozen just doesn't, I can't see your facial expressions, I'm blind. Okay, so, we got rid of this. Let's get rid of this. How many carbons are going to be in our, the thing we're going to add to this? The blue thing.
4.
4, right? Because we have to break this here. That doesn't count as its own carbon. I mean, this counts as a carbon, but not as a blue carbon. So we have that. This is the carbon that ends up attached. So, we chuck a leading group on there. Voila. And then just to go from this step to this step is NaOET or OET minus, right? Probably in ethanol, because basically we're doing a basic situation, basic solution. Yes? So we find our carbonyl carbon, and we take everything that's connected there off of it. We turn that into an ET and just mirror it. And then we get these guys gone. We give them a leading group. Does that make sense? Is that good, bad, all right? Kind of a lot first thing in the morning? Okay. Let's see. So, new stuff, conjugate addition. We're going to do a Michael reaction. What do they actually have? Let me just see where it... Okay. See, I always get excited and immediately want to start doing the mechanism, and yeah, there's a couple slides to talk about before we get there. So, microreaction. This is when we take a nucleophile and we react it with an alpha beta unsaturated ketone. Wait a minute, we take a nucleophile and react it with that? Because right now it's starting to look like we're about to call this double bond an electrophile. We've never called a double bond an electrophile, right? Double bonds are nucleophiles. I mean, weak nucleophiles, but like they're nucleophiles, right? So Why is this one special? Why does it get to be, bless you, an electrophile here? Or am I just picking shit up? Let's do some resonance. So, let's do this nice simple one. Let's do resonance structures of this. So,